We are doing series of videos on homogeneous differential equation. There is a continuation of that series in this video also. So in this video, we are going to show that the given differential equation is a homogeneous differential equation, and we will try to solve the homogeneous differential equation. Hi, I am Syed. Welcome to my channel Educate with Syed. So the question is, show that the differential equation x cos y by x plus y sin y by x times of y into dx is equals to y sin y by x minus x times of cos of y by x into dy. Question is, show that the differential equation x cos y by x plus y sin y by x times of y dx is equals to y sin y by x minus x cos y by x times of x into dy is homogeneous, and solve it. So let us first try to express it in the form of dy by dx. So retain this value as it is, this complete expression as it is, x cos of y by x plus y sin of y by x times of y, alright, and send this entire expression on the left hand side, cross multiplied, that will be divided by, you get y times of sin of y by x minus x times of cos of y by x times of this value x is equals to, you are left out with the dy over here, and the dx which is there, you just try to cross multiply it, it becomes divided by dx. Therefore, I can rewrite this as dy by dx is equals to, so you have y by x over here, you can just write down that y times of this entire expression that you have, that is x times of cos of y by x plus y times of sin of y by x, it is whole divided by, again you are having over here in the denominator x times of this complete expression, x times of, you have y into sin of y by x minus x into cos of y by x. If I take the differential equation in the form of dy by dx is equals to f of x comma y, then this entire expression can be taken as f of x comma y. So therefore, you have the value of f of x comma y to be equals to y times of the entire numerator value, it is whole divided by the denominator x times of this entire expression y into sin of y by x minus x into cos of y by x. Now we need to show this given function is a homogeneous function. For that, you have to replace the value of this f of x as lambda of x and y as lambda of y. Then if you get back this expression lambda power of 0 into f of x comma y, then this function f of x comma y will be called as a homogeneous function of degree 0. So here f of x will be called as a homogeneous function of degree 0. Now let us try to replace the value of x as lambda of x, put x is equals to lambda of x and put the value of y to be equals to lambda of y. So if you put the value of x to be equals to lambda of x and y as lambda of y in this expression, we get f of lambda x comma lambda y is equals to, so y will be lambda of y, x will be lambda of x times of cos of this y will become lambda of y divided by x will become lambda of x plus y will become lambda of y, then sine of y by x, y will become lambda of y, x will become lambda of x. It is whole divided by the denominator value. You have x, x will become lambda of x, y will become lambda of y into sine of y will become lambda of y divided by x will become lambda of x minus x will become lambda of x cos of y will become lambda of y, x will become lambda of x. We see that this lambda values will cancel out. All these lambda values will cancel out. Now further we will try to simplify it. Now here lambda is common, so I can take this lambda outside. This y will remain as it is. Now the remaining terms will be x into cos of y by x plus y into sine of y by x. It is whole divided by, in the denominator also you have lambda over here and lambda, so you can take lambda common outside. So lambda of this x value as it is. So since lambda is removed outside, we are left out with y sine of y by x minus x cos of y by x. Further we can see that this lambda and lambda will cancel out. Now try to check, is this expression that we have over here, is it not f of x comma y itself? Just check it. It is the same f of x comma y. Therefore, this function we have got it as f of x comma y. So this function we have got it as f of x comma y. Or I can rewrite this as left hand side is the same, lambda power of 0 into f of x comma y. So when you get in this form, we can say that the given function f of x comma y is a homogeneous function. Of degree 0. So if this function is a homogeneous function of degree 0, then the given differential equation over here, then this given differential equation will be a homogeneous differential equation. Therefore, the differential equation is a homogeneous differential equation. Now we need to solve the homogeneous differential equation. So the differential equation is nothing but dy by dx is equals to, it is y times of, we have x into cos of y by x plus y into sine of y by x. It is whole divided by, you have x times of y sine of y by x minus x times of cos of y by x. If you want to solve this homogeneous differential equation, we have to put the value of y to be equals to v times of x. If further simplify this one, if you want to find out the value of v here, just cross multiply that x on the other side, will be getting y by x. If you cross multiply x, you will be getting y by x, and this y by x will be v. Let us try to differentiate this one with respect to x. Differentiate with respect to x. So we get the value as dy by dx is equals to, on the right hand side we have product v into x. So let us use the product rule over here. v into differentiation of x will be 1. X into differentiation of v with respect to x will be dv by dx. Therefore, we have dy by dx is equals to, it is v times of 1 will be v plus you have x into dv by dx. So, let us try to substitute this back over here in this equation. If you want, you can take this as equation number 1. So, equation 1 implies you have dy by dx, which is nothing but v plus x into dv by dx is equals to, on the right hand side you have y value is nothing but vx times of, you have again y value is vx into, you have x cos y by x. So, let us replace the value of y as vx, retain this x as it is, it is cos of y value is vx divided by x, next term plus you have y can be replaced by vx into sine of y can be replaced by vx by x. So, y is vx into sine of y is vx by x, that is the numerator value, whole divided by, in the denominator you are having x times of y into sine y by x times of y value is vx into sine of y by x, y value is vx by x, y sine y by x, next term is minus x cos y by x minus x cos y by x, y is vx by x. You can further see that this x and x will cancel out, this x will cancel out here, this x will cancel out, this x will cancel out, this x will cancel out, right. We can take x common from here, v as it is, I am taking x common outside, we are left out with cos of v plus v times of, since x is taken common outside, we are left out with sine of v, it is whole divided by, in the denominator also we can take x common outside, we will be left out with v times of sine of v minus, since x is taken outside, we are left out with cos of v. How this x and x will cancel out, you can just multiply this v inside, that becomes v times of cos of v plus v into v will become v square times of sine of v whole divided by, in the denominator we have v sine of v minus cos of v. So, since this entire expression is in terms of v, you can even take this v on the other side, x dv by dx as it is, send this plus v on the other side, it becomes minus of v. So, now we can take the LCM over here, LCM is v sine of v minus cos of v. You can just cross multiply this along with this v. So, this numerator will remain the same, v cos of v plus v square sine of v minus v times of, you are cross multiplying, it becomes v sine of v minus cos of v. Further we can simplify this one, this term as it is, the next term also as it is, multiply this minus v inside, minus v square sine of v, then minus of minus will become plus v cos of v, it is whole divided by, in the denominator we have v sine of v minus cos of v. Now, you can see that plus v square sin theta minus v square sin theta, we see that plus v square sin v minus v square sin v will cancel out. We are left out with v cos v plus v cos v. How many times? It is 2 times of v cos of v whole divided by the denominator term v sin of v minus cos of v. Let us try to separate the variables. Let us try to separate the variables over here. Let us take this v value on the other side. and send this x value on this side. So we get v sine of v minus cos of v, that is divided by 2v cos of v, dv is written as it is. Now dx and x is sent on this side, dx will come in the numerator, x will come in the denominator. Now this is in the variable separable form, you can just integrate on both the sides. So we will try to integrate on both the sides. So if you integrate, we get integral of v sine of v minus cos of v divided by, it is 2v into cos of v times of dv is equals to, you have integral of dx by x. Now let us try to split this one. If I try to split, we have v sine of v divided by, it is 2v cos of v, then minus of, again we have cos of v and then divide that by 2v cos of v times of dv is equals to, integral of dx by x will be nothing but log of mod x plus the constant of integration c. Now we see that cos v will get cancelled, one v will cancel out from here. We are left out with integral of 1 by 2, the constant I will take it outside, we have sine by cos will be tan, so tan of v. Now try to apply separately the integral for the first term and separately the integral for the second term. So tan v into, it becomes dv, then minus of, apply the integral for this one, again 1 by 2 is common, we have integral of 1 by v into dv is equals to log of mod x plus the constant c. So it is half times of, what is integral of tan v? Integral of tan v is nothing but log of mod secant of v minus half times of, it is 1 by v into dv. So it is of the form integral of dx by x will be log of x form, therefore it is log of mod v, that will be equals to log of mod x plus the constant c. So multiply the entire expression by 2. So this 2 and 2 will get cancelled, we are left out with log of mod secant of v, again multiply this by 2, 2 and 2 will get cancelled, we get log of mod of v, multiply this by 2, it becomes 2 times of log of mod x plus you are multiplying this by 2, so 2 times of c, but the value of v is nothing but y by x. So initially we have taken, you can observe over here, we have put y is equals to vx, therefore the value of v will be what? Y by x. So we will substitute back the value of v to be y by x over here, it becomes log of mod secant of y by x minus log of mod of y by x is equals to, now this is in the form of log of m power of n, which can be written in the form of n log of m. So we see that the given expression is in the form of n log of m, that can be written as log m power of n. So therefore it becomes log of x square, because x square is a positive value, you can remove the mod, plus, now 2c is a constant, this constant can be replaced by some other constant as log of c. So we have taken this 2c value to be equals to another constant log of c. We have another property log of m by n, which is nothing but log m minus log n. Now the given expression is in the form of log m minus log n, which can be written as log m by n. So therefore you can write it as log of mod secant of y by x divided by y by x, that will be nothing but, this is in the form of, we have another formula log m into n, which is nothing but log m plus log n. So this given expression is in the form of log m plus log n, which can be written as log m into n. So therefore you can write as log x square into c or c into x square. So you can just eliminate this log from both the sides. So we will get secant of y by x whole divided by y by x is equals to, it is log of, is equals to cx square. You can cross multiply this yx on the other side, it becomes secant of y by x is equals to cx square times of what? Y by x. One x will cancel out, will be left out with secant of y by x is equals to cx into y. The secant can be represented as 1 by cos, so I can write 1 by cos of y by x is equals to c times of xy. If you cross multiply this cos on the other side, we are left out with 1 is equals to cxy into cos of y by x. Or cross multiply this c, it becomes 1 by c is equals to xy into cos of y by x. So 1 by c is again a constant, we can replace this by some other constant, say c1 is equals to xy into cos of y by x. So what we have done, we have just replaced the value of 1 by c to be c1, or I can rewrite this as xy into cos of y by x is equals to c1. So that gives us the solution for the differential equation. So that's all I have for today. If you like my video, please subscribe to my channel. Thank you.